Given the table for m of x equals 5x cubed minus x squared minus 180x plus 36 and n of x equals x squared minus 36, calculate the values for their quotient s of x equals m of x divided by n of x. Use the patterns and differences in those values to determine the degree of the quotient function s of x and to write the polynomial function for it. All right, so in this table, we want to take each m of x and divide it by n of x to get our quotient s of x. And then from that, we can find the finite differences in function. And so m of x divided by n of x here, 36 divided by negative 36 gives us negative 1. Negative 140 divided by negative 35, I'm just going to use a calculator for this, gives us 4. And so on, just dividing each one in that same order. I'm just going to go ahead and fill in the rest of the table. And so I filled out the rest until x equals 5, but at x equals 6, notice that m of x is 0 and n of x is 0. And so we can't actually divide anything by 0, even if it's 0 divided by 0. It's not allowed, and it doesn't even make sense to divide something by 0. And so this one does not exist. And so it's not going to be valid in our domain at all. We'll just put here NA because that's not going to apply. And we can also just note here that x will not be able to equal 6 in our function. And so now let's go ahead and find our finite differences. So note that delta x is again 1 here since we just go up by 1 every time. And then on the right side, 24 minus 19 is 5. 19 minus 14 is 5. 14 minus 9 is 5. And so on. We actually get a difference of 5 for each one. And so since the first difference is the same, then this is going to be a linear function, which is y equals mx plus b, or in this case, s of x equals mx plus b. And so to find m, then we need to take delta y divided by delta x. And so delta y in this case was 5, and then delta x we know is 1, and so 5 divided by 1 is just 5. And then the y-intercept is a b, and so when x equals 0, then we notice that s of x equals negative 1. And so we know that b will equal to negative 1. And so putting that into our equation, then we get s of x equals 5x minus 1. And then we also just need to note that when x equals 6, we don't have a valid value there. And so we can write here that there is a domain restriction, and so it's going to be the set of x values such that x is in the real number set, but x cannot equal 6, or is not equal to 6. And so that we will have that restriction there. So here's our final answer. The quotient is best represented by the first degree linear function s of x equals 5x minus 1 with a domain restriction such that the domain of s of x is the set of x's such that x is in the real number set and x is not equal to 6.